This afternoon, I will talk about the science in the pandemic, color pattern in shrimp Litopenaeus vannamei. As Andrea said, José Maria Monserrat, I work at the aquaculture program, and also I'm a professor at the Institute of Biological Science. So my destination was the Virginia Seafood Agricultural Research and Extension Center at the city of Hampton, Virginia in United States. This Virginia Tech Station remains on the edge of Hampton River in the Chesapeake Bay. So the original idea, the original project was to analyze the use of bioactive supplements for shrimps, Litopenaeus vannamei, reared in a biofloc technology system, or BFT. The fact is that I arrived in the city of Hampton on the 1st of March, 2020. And during the next 2 weeks, it was a huge arousal of the pandemic, COVID pandemic. So this led to a closure of the lab. And then I was a problem because I haven't a physical lab to perform my research. So obviously I went to a plan B. At the same station, it was another professor from PrInt-FURG and colleague, Dr. Dariano Krumenauer. He was performing his postdoc at the Virginia station, at the Virginia Tech station. He was analyzing the effect of the COPAD Acyclops panamensis on the microbial aggregates enrichment in the shrimp Litopenaeus vannamei, reared in a BFT system. We were lucky that he finished an experiment right before the lab closure. At the same time, I knew that some supplements and bioactive compounds can affect the color pattern of the shrimp Litopenaeus vannamei. In fact, in this year, 2020, my research group published a study where we use an Amazonian fruit, acai, Euterpe oleracea, as a supplement for the feed of shrimp Litopenaeus vannamei. You can see in the table 2 color parameters that you can measure with a digital colorimeter. Right in the up left corner, you can see the machine, the apparatus. For example, the lightness value, L asterisk, is a parameter that ranges between 0, that defines a black color, and 100, that defines a white color. Also, there is another parameter, the A asterisk parameter, that defines the green-red axis, where a negative value means a greenish color, where a positive value means a reddish color. As you can see here in the table, in this paper that we published last year, at the 10% of acai inclusion, we observed that shrimps were darker and reddish. So the point was that in the experiment of Dariano experiment, he employed a supplement, in fact, COPADs, that obviously contain several bioactive molecules. So the idea was to perform a color analysis on the shrimps that Dariano had employed in his last experiment. The problem was that we haven't a digital colorimeter, So the idea was to create some kind of protocol using online and free software just to analyze the photos that we can take of the shrimps of Dariano experiments. So the new plan was then to analyze the color pattern of shrimps of Dariano experiments, just to analyze the influence of COPES supplementation on the color of the shrimps. The manager authorized us to take photos of frozen shrimps during 2 days. This was allowed for us. So we bought a portable photo studio, and you can see here the setup, the working setup. Here you see the portable photo studio. Here we are taking pictures to every shrimp of the Dariano experiments. And here in the last picture, you can see, just let me use some pencil. In the last picture, you can see some color reference cards that I also bought. In fact, we employed a white color reference card just to put all the pictures on the same basis, on the same white color basis, just to avoid any kind of bias between treatments. So to create this protocol, we follow several steps. The step one was obviously to put all the pictures on the same white balance using this reference white color that I bought at the lab. We employ the free software Picasa. I found some protocol online that you can, for example, select different spots of the white card. In our case, we opted for select 3 different spots just to say to the program, this is the white, and then the program put all the picture on this, taking into account this reference white color. We performed this operation obviously for all the pictures, and then we went to step number 2. The point is that our color analysis was an analysis of the whole picture. I was afraid that, for example, the shadows that you can see here will be considered by the program, and this can eventually affect some color parameters, as an example, the lightness parameter, because it will be adding some a dark color to the whole picture. So the next step was to eliminate the shadows. For that, we employed a free online software, Background Banner. This is a nice software because it offers to you several options of, for example, a white background. You can choose white, black, or whatever. But in our case, we selected a white background. The program offers to you several options, as you can see here, here, and here. And then also you can improve the best option, and you can improve manually just to eliminate some little shadows that remains after the software performs its work. So you have, this is the final result, a shrimp that have been performed by a white balance and also by a shadow eliminating, putting on the photo a white background. Just to show you, You can see the original image and also the photo after the background burn complete the task. Then we finally we define the last step, step number 3, that it was properly the color analysis. So I knew that there is an online free software, the image color summarizer, that you can upload different photos, and the program will perform a color analysis on the whole picture. That means including the background, not only the shrimp, but also the background. So you can see here an example of the output of the software. You can see in this rectangle the L asterisk parameter, A asterisk parameter, and the B asterisk parameter. As I said, the program analyzed the whole picture, so it offers a mean or a median of each color parameter, taking into account the whole picture, that is not only the shrimp, but also the background. So, the Ariano experiment considered 3 treatments. You can see here some photos of thawed shrimps. Treatment 1 was shrimps reared in a clean water with CAPES. We employ the code CW+C. Also, the second treatment was shrimps reared in a BFT system, no CAPES added. So the code of this second treatment was BFT. And the third and last treatment was shrimps reared in a BFT with CAPES added. So we call this treatment BFT+C. Also, is a common practice to analyze the color pattern after cooking the shrimps using 70 Celsius degree during the 2 minutes, just to see the cooked shrimps, how it's like. So again, you have the 3 photos for each treatments of the 3 treatments of the Ariano experiments. As a result, we observed in thawed shrimps some difference in the B asterisk color parameter and also in the C asterisk color parameter. B and C are 2 different color classification. You have one color classification that consider the L, the lightness parameter, the A and B asterisks, and another color parameters consider the L lightness, C, that is a chroma, see, higher C values mean more vivid chroma, and also the third parameter that we call hue, H. So the B color parameter, the B asterisk color parameter, range from negative blue to positive value, that means yellow. So you can see here that from a statistical point of view, animals that were reared in clear water plus CAPES presented a more yellowish color than the animals that were reared in a BFT system. As you can see, there are significant difference in these values. At the same time, animals maintained in a clean water plus CAPES supplements there also showed a more vivid chroma because the value was statistically higher than the values observed in the animals maintained in the BFT system, meaning that in fact, the treatments, mainly with the putting the animals with or not with BFT was influencing, was a factor that was modulating the color parameter of Litopenaeus shrimps, Litopenaeus vannamei shrimps. This idea was when I come back to Brazil, we employed this idea, this procedure, to some applications in our studies that consider the adding of lyophilized acai to Litopenaeus vannamei post-larvae reared in a BFT system. We just put on the water lyophilized acai at different concentrations. You can see here on the left the experimental procedure. Different colors means different acai concentration. The acai is mixing with the BFT, with the solids in the water column. And you can see on the right animals that were at the 4 different treatments, control, animals maintained with the 5 milligrams of acai per liter, 20 and 80. So it seems to present some kind of color difference, but in fact, analyzing, using all the procedure of 3 steps procedure to analyze the color pattern of the pictures, we in fact observed that the post-larvae maintained at the 2 highest concentration of acai were darker. So again, the influence in this case of another supplement is a fruit will influence the color pattern, and obviously now the idea is to see if this difference in color pattern reflects some kind of difference in, for example, the antioxidant content, or just to offer you a spoiler of the next chapters of this story. So I would like to say thanks a lot to several people. At first, to the sustainability in coastal and oceanic ecosystem cluster of excellence in the extreme south of Brazil. Also to all the guys of Virginia Tech people. Thanks a lot. Really a great muito obrigado to Dariano, because it was extremely important for me to do some kind of research in these bad and extreme conditions during the pandemic. Also, thanks a lot to my PhD student, Gressica Colombo. And last but not least, thanks a lot to CAPES for the fellowships. And obviously, thank you very much to you for your attention. Thank you.
Thank you, José. I was glad to see that you found a plan B for the very regrettably situation that we faced very soon after our arrival. The pandemic had to made the lab to shut down, and then you could not proceed with your plan B. So I was glad to see that you and Dariano found a plan B. Thank you for being very creative and valuing the investment made. Very good. Thank you.
Okay, you're welcome.
You are open also for questions, comments. Yes.
I have a question if nobody has. José, the difference between the yellowish and reddish in terms of market, how does it influence the desire of the consumer?
Okay, in fact, a reddish shrimp possesses a higher market value. So it's good a shrimp to have a reddish color. And with juveniles, Litopenaeus vannamei, the work that we published last year, in fact, showed a reddish color. This is good. This is good. But also they can be darker because the suspension solids as in a BFT system, and also because the acai is has an intense violet color, the animals can acquire a more darker color that perhaps it means that they also have more antioxidants. So the idea is that we can employ a very quick and very cheap system just to make a quick analysis, perhaps, of other variables, including the biochemical variables that are interesting for us, as the antioxidant competence and also the antioxidant concentration of polyphenols, flavonoids, and other molecules.
Thank you. So if the antioxidant made the shrimp to become darker and violet and towards the violet, you might have perhaps some issue for marketing. So do you think there will be a possibility of adding acai to the experiment and at the same time avoiding this violet and putting something else to make it more dark, reddish?
I don't know, but it depends on several factors. If you can prove that a darker color is good in terms of, for example, you can say to the consumers, well, if you add acai to the shrimp's feed, they will show darker because they have more antioxidants. So this is a functional food. This is good. I have no expertise about the psychological perception of consumers about the colors. I don't know if a violet could be nasty. I don't know. I really don't know. But you can, the color, and this is our working idea at the present, is that the color perhaps will say to us if the animals are catching the antioxidant that we are offering directly in the water column.